And finally, natural gas is a clean fossil fuel. So we'll investigate this to some degree of depth. But we'll start at the big picture questions. Why would the industry make a claim, why would they want to make a claim that natural gas is a clean fossil fuel? Who cares about clean fossil fuels? Do we care? Okay, now I got to warn you here, be careful. There are people in this audience, there's a significant percentage of people in this audience that do not believe that global climate change is occurring. And there's a significant percentage of people in this audience who might believe that global climate change is occurring, but don't believe that humans have anything to do with it. And for those of you who are in those two categories, you probably want to hold your ears because you're not going to like what I have to say. But that's just the way it is. You're you, I'm me. Even my students at Cornell choose sometimes to sort of tune me out and not listen to what I have to say, but that's okay. So this is data. Horizontal axis is year, starting from 2006 right up to January of this year. And the vertical axis is the concentration of carbon dioxide in the Earth's atmosphere as measured in parts per million. And the black line is the mean measurement, and the red line is the seasonal fluctuation. So look at the black line, and you'll see that overall, for the past 5 years, as it has for the previous 25 years, the concentration of carbon dioxide in the atmosphere is monotonically increasing. And it's increasing so that in January of this year it was roughly 390 parts per million. It's increasing at roughly 2 parts per million per year. And if you believe the vast majority of real scientists, who have explored this question of global climate change and the impact of one greenhouse gas, carbon dioxide, by the time we get to 450 parts per million, we will have reached what's called a tipping point. An instability will occur in the Earth's atmosphere, which will result in faster warming of the planet, an increased frequency of severe storms, So we have, if you do the math, we have about 30 years. If it's increasing at 2 parts per million per year, and we don't want to get anywhere near 450, we've got about 30 years to decrease the rate of increase, which would be good, or actually decrease the concentration, which would be better. So to decrease the concentration of carbon dioxide in the atmosphere, we have a really difficult problem for a very fundamental reason. All the carbon that we have put and that Mother Nature has put into the atmosphere right now, for all practical purposes, is there forever. Carbon dioxide lifetime in the atmosphere is 1,000 years. So any carbon dioxide we put into the atmosphere by burning fossil fuels since the Industrial Revolution is going to be there through our lifetimes, our children's lifetimes, and for the next 30 generations. You can't suck it out very easily and get it out of the atmosphere. So the only thing you can do is stop increasing it, or at least stop the rate of increase of it, slow it down. Got that picture? Okay, so that's background. What's that got to do with the myth that natural gas is a clean fossil fuel? Okay, we'll get to that. But recently, about a month ago, I happened to be honored to be one of the co-authors of a paper, which again appeared in a very prestigious journal, Climatic Change Letters. It was peer-reviewed. It took us 2 years to write the paper. It was a 6-month-long review process with 2 revisions, and was published. It's called The Methane and the Greenhouse Gas Footprint of Natural Gas from Shale Formations, and it investigated the following hypothesis. Is natural gas a clean fossil fuel? Well, clean relative to what? Relative to other fossil fuels, notably coal and oil. Those are the 3 principal fossil fuels that we burn today that put carbon dioxide in the atmosphere. Coal, oil, natural gas. So we wanted to test that hypothesis. That's what science does. Okay. So let's look at the truth to the myth. As I said so many times tonight, inside of every one of these myths is a kernel of truth that makes you want to believe the whole myth. This is a graph. I'm sorry about all the graphs and bar charts tonight. I hope I'm not really turning you off, but the horizontal axis shows for shale gas, unconventional gas, conventional gas for coal and for diesel oil, the number of grams of carbon that are emitted when it's burned per megajoule of energy. I'll explain that to you in another way. I take a quantity of coal, a quantity of oil, and a quantity of natural gas that produce the same amount of energy, measured in joules, in this case, megajoules. And now I ask, if I burn them, how much carbon dioxide do I get? And what you get is well known. We didn't do this science. This was done years and years ago and everybody agrees. You get more carbon dioxide out of burning coal and burning oil than you get out of burning gas. So natural gas is a clean fossil fuel from the point of view of how much carbon dioxide is emitted when you burn it. That's true. Incontrovertible. Nobody would argue with it. Not even Energy in Depth would argue with that. No, they would. Never mind. They might get confused. Are you listening, Chris Tucker? I'll arm wrestle you any day. Okay, so there's the kernel of truth. But that wasn't the hypothesis we were testing. We were testing the hypothesis, is natural gas a cleaner fossil fuel than the other fossil fuels over its life cycle? From the time that you drill for it, to the time that you frack for it, to the time you get it to the surface, that you clean it, you dehumidify it, you compress it, you store it, and you transmit it, and you burn it. That's the life cycle. That's the proper question to ask. If you're going to say this fossil fuel is better than that fossil fuel because it has less of an impact on global climate change, you're not allowed to just say what happens when you burn it. This is insufficient information. This is bad science. You haven't answered the question. So now we have to ask, while you're producing these different kinds of fossil fuel, aren't you also burning fossil fuels? Yeah. And don't you have to produce them somehow, store them somehow, clean them somehow, transport them somehow? Yes. And while you're producing these fossil fuels, is it possible that you're also emitting another greenhouse gas? Not just carbon dioxide, but the second most important greenhouse gas, methane. What's natural gas? Methane. So we had to do the investigation. We had to do the best science we could with the best data we could find, which was largely industry data. And I'm going to show you what the results are. So there's the truth part of the myth. So let's look at the methane concentration in the Earth's atmosphere. I just showed you the carbon dioxide concentration. This is a long-term record. This is the year 1000. And here's the year 2100. And here we are in the year 2010. What do you notice? Well, what you should notice is for a very long period of time, the methane concentration in the Earth's atmosphere was fairly somewhere around, I don't have my glasses on, 700 parts per billion. And then somewhere around the beginning of the Industrial Revolution, the concentration of methane in the atmosphere started to increase rather abruptly. Now remember, and I'll show you in a minute the numbers, methane, molecule per molecule. A molecule of methane, a molecule of carbon dioxide, which one is better at trapping heat? Methane molecule. Okay. And I'll show you by what factor in a minute, but keep that in mind. So if we zero in on this data, and let's just look at the last 10, 15 years to get an idea of what's happening recently. So again, this is year 1987 to 2010, latest data. Methane concentration in parts per billion in the Earth's atmosphere. And as you can see, it has fits and starts. But it's increasing. This is another graph. Again, horizontal axis is year. This is the world consumption of dry gas, natural gas. All the other hydrocarbons have been removed, so if you're just burning methane in trillions of cubic feet, this is the worldwide consumption. As you can see, since 1980, it has been increasing until 2009 when we had a little sort of worldwide depression. And industry sort of shut down a little bit, so the burning of natural gas actually decreased in 2009. But the data I just showed you is that methane concentration in the atmosphere is increasing, burning of natural gas is increasing, and so we are putting more and more carbon dioxide into the atmosphere by burning natural gas, but we're also increasing the emissions of methane into the atmosphere by the production processing, compressing, transporting, storing, and transmitting natural gas. So let's do a better job on this table by finishing it. There is the truth part. Natural gas is mostly methane. Methane is the second most important global greenhouse gas behind carbon dioxide. And now I'm going to show you some science. Actually, I'm going to tell you some science. I can't show it to you because it's pretty complex.